This is the second video. In this video, I'll going to discuss step response and ramp response for this circuit. As of now, I didn't discuss ramp response for the second transfer function, which is the part of standard transfer function. So let's discuss. See, this is h of infinity by omega p s upon 1 plus s by omega p. If you multiply inside, then it will become s plus omega p. Then if you want that ramp response, actually first I discuss ramp response and after that I will discuss step response. Okay, so if you want a ramp response, then you will multiply by the s square to this term, then this ss will count. Then you just plot the step response for this function, because if you see, then this is the transfer function and you just plot the step response for this transfer function, then it will become the ramp response for the circuit. So if you see, then you just calculate the initial and final value. So for this initial value, what will be the initial value? You just multiply with s to this transfer function, and this, let us suppose this is h of s, h dash of s, and okay, I just put s is infinity. Then see, if you put s as infinity and multiply with s, then ss will come, and you put s as infinity, then that will become 0. So initial value will be 0. So initial value will be 0 and the final value will be ss gone, and s you put 0, then h of infinity upon omega p. So response will be look like this. So for this circuit, your ramp response will be this, and if you calculate h of infinity, I already discussed in the last video, h of infinity will be 1 by 2, and omega p for this circuit, this is 2 RC, so 2 will gone, this is RC, this is the final. Okay, so your ramp response for the circuit is look like this. So this is you calculate by the your Laplace, using Laplace and KVL and KCL. So I want to discuss by the intuition also. So see, by the intuition, if you want, then see, just because this is a little bit tricky, so just pay more attention. So see, if you provide a ramp signal to this circuit, so at t is equals to 0, your capacitance will short circuit. This will short circuit means this is vi by 2 means this is RT by 2 means 0. Okay, so it is approximate, it is 0. Okay, because at t is equals to 0, this input will 0, then your output will also be 0. So your output will 0 at t is equals to 0, and at t tends to infinity, this will provide more, this capacitance will provide more impedance. More impedance means impedance is very high, more impedance. Then this circuit will look like only C, means this is only OC. So this is more impedance, then it will look like only R, because in the parallel less impedance will be considered. So this is R, and this will be my capacitance C. And because this capacitance have very high impedance, so total this my input drop at t is equals to infinity will be here only. So if you see the current through the capacitance IC at t is equals to infinity, and C dVc upon dt, then I already told you this capacitance impedance is very high, so total input drops is approximately dropped across the capacitance, so this will become C dVi upon dt, and your input signal is a ramp with slope 1, then it is become C only. So if you see the output at t equals to infinity, what will be the output? IC into, this is ut, IC into R. So IC into R means RC u of t at t equals to infinity. You see, at t equals to infinity, RC into, and you know this will be the increasing exponential, then you can directly write this is 1 minus e to the power minus t upon tau. This is h of infinity, means this like. Okay. So this will be the your final function. Okay. So this was the ramp response for the circuit. So now I am going to discuss the step response. I think step response is very easy. You just calculate the h of 0 and h of infinity for the circuit, or initial value into the final for the circuit. So see, at t equals to 0, if you see, then your circuit is at t equals to 0, this is short means 1 by 2, and at t equals to infinity, this will be the open means this is 0. So at t equals to 1 by 2 into 0, this is the step response, and this is tau means 2RC. This is, so it will be e to the power minus t 2RC. So your total 1 by 2 to the power minus t 2RC for the step response. If you see from here, then you know the transfer function for this. So transfer function was SRC upon 1 plus 2 SRC. So for the step response, multiply with the S, then SS will come, and you left with RC upon 1 plus 2 SRC. So for this RC upon 2RC to the power minus t upon 2RC, RC count means 1 by 2 to the power minus t 2RC much. This is the integration, and this is like the calculation. So this is the step response. So like this, for the all circuit, all passive circuit, you can calculate impulse, step, and ramp response, and earlier I discussed Bode plot and phase plot. So you also discussed plot your Bode plot and the phase plot for any kind of passive circuit. So I thought this will help you a lot. So thank you. If anything you feel like wrong in the circuit, please comment and correct me. Okay, thank you.